Here we have our arm segment 2 part, the second of 3 arm segments in our mechanical arm, which connects to our base first arm segment, which we just covered, and our third arm segment, which we are yet to cover. This one was, they're both connected, they're connected to both arms through a friction hinge, and the first 4 items of this feature are nearly identical to the first part we just covered. It was taken as a save as file from the previous part and then adjusted from there. The only change is that this cut extrude, instead of going 12.5 on one side and 20 on the other, it's 12.5 equal both sides. The reason it was 20 on the other one was to create a little bit more mass at the bottom where it connects to the base piece and sits in with the pegs. Now that this one will be rotated and moved around, it has no need for that. The first difference made here was by creating a second extrude on the other end of the cylinder. The difference between this extrude, which will also have heat inserts and connect to the other arm segment than the one that we already have designed, is that it was going to be perpendicular to the first one. This allows us to get more degrees of freedom, so one arm rotates one direction and the other one, the second arm, will rotate in another, and this will be allowed to us by the hinges being aligned perpendicularly. The difference in this is that instead of it being, it's also 25 high, the difference is instead of being 12 thick total, it is 20 thick total. The reason for this is because what will be shown later in the part, that the cut extrudes where the heat inserts set, we're not going to be in the side, they're going to be in the top. The reason for this is that when we have our friction hinges set on the side, there can be a little bit of different degree of freedom. If you put it on the side, it causes, when you go backwards, it causes for some very minimal contact at some, if you push it all the way back between the 2 arm segments. That doesn't matter on the first piece, which allows us to put it on the side and give us full degree of freedom going forward, which is the most important for the base piece and the connection to this piece. But this now second piece connection to the third piece, which instead of rotating up and down will rotate left and right, needs to not have a constraint to one side and not favor one. As the first one favors moving front to the front more than does the back, this one needs to not favor left and right equally. We then put the same 10mm fillet that we did on the previous piece, but this time we put it on both ends, and same goes for the 5mm fillet. Both the 10mm fillet being on the edge of the cylinder, and the 5mm fillet being at the edge where the cylinder and this rectangular extrude comes from. Now on this extrude that we have just created, we put our cut extrude holes. These are the exact same diameter and depth as all our other M6 heat insert holes. They are 8.75 millimeters in diameter, and they are 8 millimeters. They're 8 millimeters deep. The sketch, same as the previous ones, were made in the assembly such that as we knew what the width needed to be, and what the diameter needed to be, we didn't know where along this extrude it would be. So we used the models of the friction hinges that we pulled off of McMaster car in the assembly and lined them up here. The edge on this one, the edge of the hinge ends at the edge of this extrude here. So correspondingly, we put the cut circle extrude where it was through reference geometry to the assembly. And the reason we made this one thicker was because on the face it needed to have this 20 millimeter total length from this edge to this edge, so that we can sit the face of the friction hinge on it. And lastly, we created 5 millimeter fillets on the inside hollow cut. This time, instead of having one of them be 10, they're both 5 because they're both 12.5 distance from the top of the cylinder. The function of this part is to connect both of the arm segments to each other. This extrude that I'm highlighting now connected to the base piece, giving us full rotational freedom to the front and partial to the back, and this extrude with the hinge sitting on the face I have selected and highlighted, giving us equal rotation from left to right, giving us altogether as much rotation as we need and allowing us to assemble the base and first arm segment alternately and screw those in with the pegs assembled differently if we need to fully rotate it, but without having to remove the fully bolted down base piece. Thank you.